Thank you for joining us here this week on windsurftuts.com. I'm pretty excited about this next series of videos. It is a fairly advanced topic on Windows engineering. I hope y'all enjoy it. We are going to be talking about, as you might be able to see from the screen here, Windows Server 2008 R2 Failover Clustering. Before we really get into clustering and start setting things up, you need to have a bit of a background on all the pieces of how clustering works, how they come together to make a reliable cluster. And so I wanted to go through, because there's some pretty important pieces that you need to know if you haven't done clustering before, or maybe you've done clustering in a Windows 2000 or 2003 environment. It has changed a little bit in 2008 and R2, so I wanted to give people kind of a rundown of the definitions of all the individual pieces and how these things work together to build an effective cluster. If you are familiar with clustering, at least in theory in 2008 R2, you might be able to skip this. I wouldn't recommend it. I will post a link to the white paper on the website, and I will actually have the definitions that we're going to go through verbally available on the website, so you can take a look at those, as well as kind of a consolidation of some of the Microsoft white papers, so it's a little easier to digest. So I just wanted to say thank you to our sponsors, and thank you to those who have been clicking those links. If you enjoy the content, please do check out our sponsors in the YouTube videos. They're just at the bottom of your screen, probably somewhere around here. They help keep the videos going. To get right into this, what is a cluster, right? The easiest way to think about a cluster is think about a cluster of grapes, right? When you pick up a cluster of grapes, there is a lot of little pieces that make up the cluster as a whole, and this is very much like it is in a Windows cluster. We have a lot of little pieces that make up the final product. And the cluster technology, Microsoft has a couple of them. There is an active passive technology, which is what you would use for like SQL databases, more dynamic data. And they have an active cluster. Let's say you have a website that is static. You got a bunch of HTML pages or ASPX pages up there, but generally the content is not changing too much. That could be a use for active. But like I said, we're going to stick with active passive, because what we're going to end up using is we're going to use and set up a MS SQL database. So an active passive cluster is exactly what it sounds like. You have one active node that is handling all the requests for traffic from your local area network or out from the internet or wherever your traffic is coming from. You have one node, in this case node 1, is handling all the traffic that is being sent to the cluster. What is going on, and that would be referred to as the active node. You have node 1 and node 2, and the nodes are just the servers that comprise the cluster. And what node 2 over here is doing is it's just sitting there and waiting for node 1 to fail over. Kind of like if you're familiar with RAID, you have mirroring, you have disk 1 and disk 2, and all disk 2 does is just have a copy of all the information that is written to disk 1. That way if disk 1 fails, disk 2 can just continue operation and you can replace disk 1. Very similar kind of concept here. So if you're familiar with RAID mirroring, you can kind of think of these servers in that context. Now, you might ask yourself, this seems to be a big waste of money to just have these powerful servers just sitting here, and it could be 2 servers, it could be 3 servers, 4 servers, etc., to just be sitting there waiting for node 1 to fail. But think about it this way. Let's say you're a business that does a lot of transactions online, and your database has to be up, and it's going to cost you, let's say, $100,000 in lost profit if your database goes offline, so you won't be able to process web transactions. Well, surely your database will cost, or your database server, if you're running a MS SQL server, will probably cost less than $100,000. So let's say you spend $10,000, $15,000 on a backup server, you still are far and away better off than if your single database server was to go down, and then you can no longer process database requests and you're losing money. So that's kind of the business case scenario for it. And again, these are I recommend that IT people become interested in business, because it makes your life a lot easier to get money for resources if you can make a business case for it. So cluster is a whole, active passive sort of activity. This is the active node in this case, node 1. This is the passive node, node 2, and a node is just any server in the cluster. So we've got that. Now, there's a way that these two nodes, the computers in the cluster, communicate with each other to see if they're up and active, and that is called the cluster heartbeat. And this is communication that should only occur between nodes. So in this case, it would occur between node 1 and 2. If we had a third node, it could occur between node 1, 2, and 3, 4 nodes, etc., etc. But this is the cluster heartbeat. It's just a very small bit of traffic that goes back and forth between each node in the cluster. It's kind of like a ping that you could think of as verifying that if node 1 is the active node, it's there and alive and working. So pretty simple to understand. It's just like if you were to test your web server and you do a ping command on your web server and you don't get any feedback, you know, oh, the web server's down, and that's not good. Side note, if you haven't seen the web server's down, it's very funny. I would Google it. So now we have this concept of a quorum. And a quorum is simply a shared space that these nodes can look at to see the current configuration of the cluster. And the quorum, it will be a shared disk. And according to Microsoft, according to the white paper, this quorum can be very, very small. It actually only needs to be 500 megabytes, so very, very low disk resource. And each one of these nodes will refer to this quorum to see the current state of the cluster. Quorum is very, very important. And whether the cluster should operate or not will be decided on the cluster itself coming to a quorum. And what that means, so in our situation, we're going to be having node and disk majority clustering. So what this means is that if node 1 is up and the disk is up, the cluster can function. If node 1 and 2 is up, right, and the quorum disk is up, the cluster can function. What happens is if node 1, let's say, goes down and node 2 takes over for node 1 and the quorum is available, the cluster resource will be available, but it would not be in a healthy state. So quorum reading in how Microsoft phrases quorum is pretty interesting. I would recommend you do some research on it. Again, maybe I'll post a white paper link or a link to TechNet. But primarily what you need to know for our node and disk majority is that if one of the two nodes is up and the quorum disk is available, your cluster will function. That's the basics of it. But the quorum disk is important. So next we need to talk about cluster resources, and the quorum disk is absolutely a cluster resource. Another type of disk, we will end up installing an SQL server onto our cluster. So not only will we need a quorum disk, but we will need this disk for our SQL cluster, right? So a disk is a resource. An IP address could be a resource. Things like that. An application or a script, things like that, is a resource. And when you put these resources together, they form what's called a service application group. So let's say we're going to be, and we will be, setting up MS SQL server onto a failover cluster. This is fun stuff, right? So now for this MS SQL server to work, the SQL server itself will need an IP address, right? In addition to all the IP addressing that we will be doing just for the cluster to work, the SQL server will need its own new virtual IP address. Sometimes it's called a VIP if you've been in IT for a while. It will need a disk. It will need its own server name, right? So now let's say this whole server is called cluster 01, right? And that's how people on your LAN can get to your cluster. Maybe your SQL server that you're installing, it will have a brand new name. These physical pieces of hardware will respond to that name, and maybe the name will be SQL Cluster 01. That name, that IP address, that disk, all goes into that service application group. So the resources together make the service application group. Okay? So just remember that. The cluster resources make up the service application group, just like the nodes and the quorum and things like that make up the cluster. So many little pieces go to make a whole. So I mentioned something called a VIP, and what really that is technically called is a client access point. So even though node 1 will have an IP address, node 2 will have an IP address, from the network, from the LAN, we don't want to address this cluster by those individual IP addresses. So what will happen is your cluster as a whole, notice the cloud around this, this is a logical grouping of these resources. This cluster as a whole will have its own IP address, and it will have its own server name, and these will all be found in Active Directory. So when your network clients are trying to access this SQL database or this cluster resource, they won't use the node IP address, node 1, or the node IP address for node 2. They will use this cluster IP address. And again, sometimes that is referred to as a VIP. Same thing for the SQL application group. If you have SQL installed on your cluster and you need to get to this SQL database, you won't use the cluster IP address. Another IP address will be assigned to that service application group. And so if you're trying to hit the cluster itself, you'll use one IP address. If you're trying to hit that SQL application group, you'll use a different IP address. Same thing if you guys remember when we did the DHCP tutorial, how I told you Microsoft recommends having a DHCP cluster for high ability. So if you had a DHCP cluster, an SQL cluster, and that cluster IP address, even though that traffic was going to the same physical two boxes, it would be a different IP address that you would be using to access those service application groups. This is a very important concept. If you need to rewind this video a few times until you get that, please feel free to do so. These are very, very different concepts, or different IP addresses. So essentially, we're talking about a logical grouping of shared resources. One of those shared resources, like we mentioned previously, is the quorum. You would have your SQL disk, and there is a specific term for it, and strangely enough, the specific term is called a shared resource, right? And a shared resource in Microsoft technology refers to a shared disk that only one of your nodes can access at a time. So, in our case, we will be setting up an SQL database on our cluster. So we have our SQL disk here that our SQL database will be using to read and write database information to. So even though this disk is available to the cluster, only one node at a time can access that shared resource. In this case, it's a shared disk. Okay. There is a modification of this when you're doing Microsoft virtualization, but it's a little bit outside of this scope. If you are doing virtualization, if you're setting up a cluster to do virtualization, take a look at that. These disks are presented usually via LUN. In our case, we're going to use a technology called iSCSI. And what iSCSI does essentially is on your old SCSI hard drives, there were these commands that would be sent down your system bus. Instead of being sent down like your PCI bus or your SCSI bus, now those SCSI commands are encapsulated in an IP packet, and those iSCSI commands would be sent over an Ethernet network to a SAN or NAS unit. In our case, we will be using a NAS unit. The NAS unit will have these different disks. You can think of them as partitions per se. These partitions will be assigned a LUN. So just like if you were to have your a 1 terabyte hard drive on a physical disk, and you say, well, I want different disks to be cut off. I want different partitions on this 1 terabyte hard drive. So like, let's say the first one you have is 200 gigabytes, the second one is 300 gigabytes, and the third one is 300 gigabytes. That would give you 1 terabyte total, and maybe this is the F drive, this is the G drive, and this is the H drive. You can kind of think about LUNs like that. And again, the LUN stands for logical unit number. And I'll show you how to set this up in the video, how to attach via the iSCSI initiator, which will be on our servers here, to an iSCSI target, which will be back on our NAS unit that we're going to use. So this is very important. You need a shared storage in order for your cluster to work. If you're a larger company, you may be using Fiber Channel. It is a dedicated optical network. It has lower latency than iSCSI, so just a little bit different. iSCSI will work perfectly fine for our tutorial session here. So we have these two servers, and they are designed for high availability. And what happens basically, so we said right now node 1 is just sitting here doing all of our processing. Well, what happens if node 1 goes down is a process called failover. So let's say node 1 is doing all of our database processing. Some sort of hardware error occurs on node 1, because we all know Microsoft never has any operating system issues. And there's an error and it fails. Based on that heartbeat that we spoke about previously, node 2 will not get a ping reply, or from node 1 essentially. Node 2 will see that node 1 is down, and the cluster as a resource and as a group will initiate failover from node 1 to node 2. So in this case, we have again an SQL service application group that was running on node 1. That service application group will almost immediately be started up on node 2 with almost no notice from the client. And if you were to be sitting and just pinging that SQL IP address that we talked about on the cluster, you would probably notice only one packet that was dropped if you were to continually ping that. So this is very, very good availability. Even in something like a VMware high availability solution, VMware, if a physical box goes down, will migrate the virtual machines to a different node, but the box has to reboot. So this is even better than something like VMware. So very, very powerful clustering options on the part of Microsoft. So let's say our node 1 has gone down. We've identified the problem. Maybe a processor went bad. Maybe a network adapter went bad, so it couldn't communicate on this back-end network here. And we replace the network adapter. We plug the node back in, and we power the node back on. There's something called failback that can happen. So let's say node 1 is a more powerful server than node 2. The cluster can be defined with a preferred node to run on. And so what will happen is when node 1 comes back on and the cluster sees that node 1 is back online, then all of our service application groups can be transferred back from node 2 to node 1. And that is referred to as fail back. So we have fail over when a cluster node goes down, and we have fail back when the cluster node comes back up. Just as a little side note, a wonderful enhancement that Microsoft has made in failover clustering in Windows 2008 R2 is the ability to place your nodes at different physical locations. So let's say you had a very redundant and high availability type of network, you know, your Ethernet network and your wide area network. You could actually move node 2 to a completely different physical location. And as long as you had a file share, it's a slightly different technology than what we're going to be using, but if you had a file share that node 1 and node 2 could get to, node 2 let's say was in New Jersey and node 1 was in Ann Arbor, as long as node 2 could get to that file share and node 1 could get to that file share, you could actually have your nodes at physically different locations. So this is wonderful, right? I mean, look at all the natural disasters we've been seeing in Southeast Asia. So let's say your one data center gets hit by an earthquake, your second data center would be still completely up and operational. Absolutely phenomenal. It is a little bit more of an advanced topic. In that case, instead of using a node and disk majority type cluster like we're going to be using, it would be a node and file share majority cluster. So maybe we'll do a tutorial on that later. If it is something you're interested in, by all means, do reading, do research. You know, if you want to stay current with your skills, you have to do a lot of reading and research on your own. So that will be the end of this tutorial for this week. I hope I've been able to give you the knowledge that you will need to follow along with the next few videos. In the next video, we are going to set up the hosts and get them prepped for the cluster install. There is some work that you need to do on each host in order to get it cluster ready, so that's what we'll tackle in our next video. Again, if you do appreciate the videos, check out our sponsors, the little advertisements at the bottom of the YouTube links, and please do visit the website. I'm going to have these definitions. I know we went through them kind of quick, so I'm going to have the definitions written out on the website so you could go through, you could look at them, you could read them. I'll also have some links to the Microsoft white papers and kind of a summary of the Microsoft white papers, so it's a little bit easier for you guys to digest. And yeah, thank you for joining us this week here on windsurftoots.com. I hope you've gotten a lot of value out of the video. I'm really excited for the next, I'm thinking this will be a 4-part series. So please stick around. I'll try to get the next video out not quite a week, in a couple of days, and get that up and posted. It'll be a lot of really juicy content. Thanks again for joining us here on windsurftoots.com.